Namaste, Javians. Today we'll be discussing about electrocardiogram or ECG. You must have heard that if a person has some heart attack or some complication of heart, the doctor advises to go for ECG where we get a long graphical representation of different waves. So that tells the proper functioning of the heart muscles. And if there is some alteration in the waves, we go for the treatment. So electrical depolarization is recorded on the body surface up to 12 leads, and the pattern of is analyzed in each lead. See, the leads are here. We use 12 leads over here. We put it on the different parts, some at the foot, at the toe, and we note down the waves of the heart, that how the muscles are working. The electrical phenomena is noted down. So we have P wave, which gives the information about atrial depolarization. QRS waves give the ventricular depolarization. T waves tells us about ventricular repolarization. So here in this graphical representation, you can see the small peak is the P wave. This gap is QRS and this small one is the T wave. See, the heart has the electrical conduction system. The specialized cardiac muscles are there that carry impulses throughout the heart musculature, signaling the chambers to contract in proper sequence. So that's why we always note down the electrical conduction of the system. Here the electrical conduction is held by the SA node, that is sinoatrial node, which is also known as the pacemaker of the heart. It is in the wall of right atrium and the basic rate is 70 to 80 and it is a normal pacemaker. It sends impulse from SA to atria and impulse to AV node via internodal pathway. Now the conduction, how it is carried. SA node through AV bundle, which is also known as bundle of His, and it is divided into R and L bundle branches, and they become subendocrial branches or the Purkinje fibers. The contraction begins at the apex. See here you can see the T wave when ventricles return to resting state. P wave is recorded when the impulse spreads across the atria, triggering atrial contractions. That means when the blood is entering, there is increased atrial contraction. Then this wave is noted down. Then we have QRS complex when impulse spreads to ventricles, triggering violent ventricular contraction. Then this QRS wave, this high peak is noted down. See, you can see the 12 lead graphical representation of electrocardiogram. This is artificial pacemaker. You must have heard that a person surgery was done and he was given an artificial pacemaker because they help to regulate the conductivity. So an artificial pacemaker is inserted which controls the conduction. Now we'll come to the innervation, that is autonomic, having sympathetic and parasympathetic. The sympathetic innervation increases rate and force of contractions, whereas the parasympathetic, which is the branches of vagus nerve, slows the heart rate. Now these are the blood supply. You can see A, L, G, H, right coronary artery, left main coronary artery, all these. You will be studying these in detail in your anatomy lectures. You can see the anterior view, that is view from the front. This is the view of the heart from front. See over here, this is the heart of a cadaver. Here you can see the different parts of the heart. See, this is the heart having, one is the right atrium, left ventricle, upper one is left atrium. This is right ventricle. This is a posterior view. We're seeing the heart posteriorly. Then again, this is the posterior view. Now this is the main flow chart. how the blood circulates. The blue lines show the deoxygenated or the impure blood, whereas the red lines show the oxygenated blood. From the body, the blood reaches superior vena cava, inferior vena cava, and coronary sinus. From here, it moves to right atrium. From here, through tricuspid valve, it moves to right ventricle, then to pulmonary trunk through pulmonary semilunar valve, and to the lungs for purification. From the lungs, the purified blood moves through pulmonary veins to left atrium, left ventricle, aorta, and this aorta and its branches supplies the pure or the oxygenated blood to different parts of the body. These are the embryological development, how the heart develops. You can see the diagrams over here and how the heart start pumping. This is the embryo, this is the heart, and the different phases of development. See, this is the diagram. These are the questions at the end. I hope you understood this session. And if you have any doubts, we can talk about in live sessions. And this session is powered by Digital 2.0 JVWU. Thank you.